Hi, my name is Ricardo and I'm your host of Math Matters, and today we're going to be discussing how the golden ratio appears throughout nature and how this is related to the golden spiral and the Fibonacci numbers. So just a quick review, if you haven't seen my video on the Fibonacci numbers and how they relate to the golden ratio, you should watch that. But a quick review on what the Fibonacci numbers are. Generally, if you start with 0, they go 0, 1, and then every term is just the sum of the previous two. So 0 plus 1 is 1, 1 plus 1 is 2, etc., etc., etc. And it goes 1, 1, 2, 3, 5, 8, 13, etc. And it goes on forever. But these are the only numbers we'll be needing today, because today I'm going to show you a quick enumeration of where the Fibonacci numbers and the golden ratio appears in nature. And that's why I'm holding this pineapple. So the first example I'm going to be showing you guys is all those spirals in the pineapple. And then I'm going to be showing you the spirals in a pine cone, another common example. And I chose these two especially because they're easy to enumerate, they're easy to count, right? It's easy to count how many spirals there are in a pineapple or a pine cone. And also, it's easy to see how the Fibonacci numbers are present in these seemingly random natural organisms. So first, for the pineapple, we're going to be examining the bottom first. So just a little close up. Here's the bottom of my nice Costa Rican pineapple. And we're going to be examining the clockwise and counterclockwise spirals. That's a little bit hard to see, so I'm going to be covering them in tape, and I'm going to color them two different ways such that you can see the two different spirals. So first, let's do the clockwise spirals. Alright, and now you have to see me struggle to cover all 13 clockwise spirals. Here goes. Alright, now that it's hastily done, it wasn't so easy to stick masking tape on a pineapple, surprisingly, you can see how each single spiral is covered by some Scotch tape. Or masking tape, rather. And some of them are inexact, that's just because the tape was hard to spiral. But these spirals mimic the golden spiral itself. And although the spirals aren't necessarily a full golden spiral, which looks more like a conch shell, it's more defined by the ratio of how many spirals there are. So these are all the clockwise spirals. So now we can enumerate them, right? We can count them. And there's quite a few of them, but I'm just going to take this black marker right here and I'm going to count them. So, let's start from this one. And 13. Okay, good. So if we get back to when we started that, we see we have 13 spirals in total. So let's mark that down. If we counted 13 clockwise spirals, we'll note that this is the clockwise number of spirals. Okay? So now it's time to do the counterclockwise. Now you guys get to watch me do this one. Okay, here goes. Alright, so now I've covered all the clockwise spirals with counterclockwise spirals. And from the bottom, you can't really tell. But if you look at the sides, we can see some spirals are superimposed. Right? So now we're going to count our counterclockwise spirals, and I'm going to mark it with a green marker. So, let's see how many we have. We have 1, 2, 'Well, we had 13 clockwise spirals. Comes no surprise that our counterclockwise spirals come out to 8. And this ratio, 13 over 8, to subsequent Fibonacci terms, equals 5. And that's how this part of the pine cone shows the golden ratio through the Fibonacci numbers. However, there's much more to explore. You can also count the leaves of the pine cone, and in fact the leaves of almost any plant. Now leaf arrangements are also shown with the Fibonacci numbers and the golden spiral. Now they're related to the golden ratio by these subsequent terms, but why is that? Well, for leaves it's especially apparent because think about the sun's rays hitting these leaves. Now if I show you this view of the pine cone, the pineapple, sorry, the pine cone later, you can almost not see the pineapple at all because the leaves have very good coverage. Now, while a pineapple's leaves don't necessarily have to absorb light, the photosynthetic pigments in the leaves have a lot more potential of absorbing the most light possible, therefore being the most efficient, if they're spread out in an array that causes a spiral. So if you look at these leaves, they cause a spiral around this way, and likewise a spiral around clockwise. Now these two spirals can also be enumerated, and I've done that while I was taping all this. It turns out that these spirals are actually in an 8:5 ratio. So the leaves follow more closely this ratio, which is also about 5. So no matter which way you look at it, nature is full of the golden ratio, and it's just another way why it's important. As I said, the golden spiral is very prevalent in pine cones, and such pineapples and sunflower seeds, but pine cones usually have one of the least spirals, so we can enumerate them. And I'll show that example in a second, but I redrew the golden spiral just to get a sense of what it looks like, and these are the squares that lie inside of it, and it looks like a very common spiral that you would see in conch shells, etc. But here, we have the example of a pine cone. Now, a pine cone both has counterclockwise and clockwise spirals. So it turns out in this particular pine cone, if you start from the center, there are fewer counterclockwise spirals than clockwise spirals. So those are some examples. And when you actually enumerate them, it turns out some much more visible example. Counterclockwise spirals, there are 8. So let's start from here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total counterclockwise spirals. So I'll erase my petty drawings. And we can see clearly that these are the beginnings of a golden ratio. These are the beginnings of a golden spiral, which get more and more complex. Now, where are the others? Well, like I said, clockwise. Now, clockwise, they're a bit more extended, right? And they're a bit more of them. And they continue as such. And let's just show how those look. And those are also quite numerous, and they have a total of 13. So, clockwise, 13. And, as you would expect, 13 over 8 is about 1.6. So there you have it. A literal example of the Fibonacci sequence golden ratios in an ordinary pine cone. And the reason this occurs is because, again, pine cones carry seeds, and they're selected for how efficiently they can carry seeds and which the most suitable way to do so. And pine cones are chosen because this is efficient, apparently, and because they can fit as many seeds as possible in such an enclosed space. And therefore they follow golden spiral. Hi guys, thank you so much for watching my video. It really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video of my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember, math matters.